Hello and good afternoon, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be our tutorial and solution set for challenge number 2, where we take a look at configuring some basic EIGRP. And so here's our scenario. We've got a colleague who's been called out on an emergency, and they started configuring the customer network with EIGRP, but then had to take off. So we're going to establish full connectivity between all the company subnets using EIGRP with process ID 1, which means we are not going to be doing named mode, right? So we're going to stick with classic mode here, autonomous system mode with EIGRP autonomous system 1. So both branches in the distribution center should get a default route. So we know that there's a couple ways we can do that. We could create the IP route quad 0 statement, and then redistribute static, or we could do a summary. And so we're even going to, we'll mix and match it on this one. We'll do, and actually I guess we'll just stick with the summary. We'll go ahead and do the summary to keep it as an internal instead of mixing and matching. And then currently the customer only has 2 branches. They're planning on many more, so we've got to limit the number of EIGRP query messages. And so what we definitely want to do there is we're probably going to be changing branch 1 and 2 in the distribution into stubs. And then we've got 2 links, and you can see that they are unequal cost links here. In terms of speed, my guess is they're going to be unequal in terms of metric, so we're probably going to be called in to use the variance. So let's get on the HQ router right now. If we need to take a look at the job aid, we can see the addresses that are being used. 192.168.1.1 here, 192.168.2.1, and then what do we have here? 3.1 and 4.1. And then we've got this Ethernet 0.0, and that takes us out to the internet. So let's jump on the HQ router here, go from user exec into privilege exec into global config, and say do show run section EIGRP. All right, so we've got nothing configured at this point. Do show IP interface brief. Let's make sure that all those interfaces that we saw, the Ethernet 0.0 being the internet connection, and then Ethernet 0.1.0.2, and then serial 1.0 and 1.1. So we are up and ready to go. So let's go ahead and EIGRP classic mode, right? So router EIGRP 1. It's always a good idea to go ahead and this is something I like to do, so passive interface default to make sure that we don't have EIGRP hello messages being sent on interfaces that aren't supposed to have the messages, where there's no adjacency that's going to be formed. So I'm going to say no passive interface Ethernet 0.0, Ethernet 0.1, and then we're going to come back for serial 1.0 and serial 1.1. And so those are the 4 interfaces that we're going to be using. And we should see, if I'm not mistaken, once we get the network statement in here, I believe that's all we've got. Do show run section EIGRP. Okay, good. So there's a couple different ways we could enable this. We could do a network quad 0 statement, but if we want to make sure that we are being as exact as possible, so let's say 192.168.1.0 .2.0, is that right? Yeah, 1.0, 2.0, and then 3.0 and 4.0. So we are only running do show IP EIGRP interfaces. We're only running EIGRP on the interfaces that we have connectivity on, that we wish to establish EIGRP peerings on. And so again, it's just those 4 interfaces, and we're missing Ethernet 0.0, is that right? And we may need to, oh sorry, 0.1 and 0.2, aha, so I missed one. So it should have been Ethernet 0.1 and 0.2. So let's say do show run section EIGRP. Looks like I passive, and so we're going to say passive interface Ethernet 0.0, no passive interface Ethernet 0.2. Then we're going to get our 4th adjacency here. And apologies for that. I actually said no passive on Ethernet 0.0, which is the internet-facing interface. And let's make sure, is it 0? Make sure I got that right. Yeah, 0.1 and 0.2. So we're going to say do show IP EIGRP neighbor. So we don't have the adjacency on Ethernet 02, and it may be because we need to configure that. So we're going to have to go take a look at that. In fact, let's see what that looks like right now. So Ethernet 02, I'm coming over here to branch 2. So let's see what branch 2 has going on. So we're going to go from user exec to privilege exec, show IP interface brief. Here it's Ethernet 00 is the interface. So then we're also going to say show run section EIGRP. And do you see anything that might be of concern here? So they've no passive the loopback interfaces, but we have no statement in there for Ethernet 00. So what we would need to do here, and might be getting ahead of myself, is to get into router EIGRP1 and say no passive interface Ethernet 00. And that should bring up, and there we go, and that brings up that adjacency with the HQ router. All right, so we've got that taken care of, and we should have, at this point, with the HQ router, if I were to say do show IP route EIGRP, so you can see that we're definitely learning some information. If I were to say do show IP EIGRP neighbors, we should have 4. And we do. So one of the next things it was asking us to do is to originate a static default route here from the HQ router. So what I'm going to do is I'm simply going to go into interface Ethernet 01, Ethernet 01, and I'm going to say IP summary address EIGRP1, and then we should be able to drop our quad zeros in here, /0. So out that link, I've set it up to originate a default route. And so if we look at the drawing here, the Ethernet 01 connection comes over to branch 1. If I come over to branch 1 and go into privilege exec and say show IP route EIGRP, you can see that we have a default static route that's coming up here to branch 1. Now let's do the same thing for branch 2, branch 3, and branch 4. Remember, the other way we could do this is we could originate a static default route and then redistribute that static default route. So interface Ethernet 02, recall the same command, interface serial 10, and then interface serial 11, and we'll pull that back up as well. So now if I were to look around here on branch 2 and say do show IP route EIGRP, I'm literally getting only a summary. And again, right, this makes sense because when we look at the configuration that we have here, there's really no need for branch 1, branch 2, or the distribution center. They don't have any other way to get to the headquarters router. So HQ just shoves a default out these links, and now that is the only way that these 3 locations, these 3 branches in the distribution center, know how to get back to HQ, but that's okay because they don't have any alternative way to get there. So this actually works well. Now the next thing we want to do is we want to also limit the scope of the query domain by turning the branches into stub. So we'll get into global config, router EIGRP1, EIGRP stub, and what is the default? In terms of what's going to be advertised, if I were to say EIGRP stub and hit enter, this is going to tear down the adjacency. It's also going to stand it back up for us and reestablish it. But again, if I come over to the HQ router and I say do show IP EIGRP neighbors detail, right, and we're looking for our peering here, there's our handle column right there, right? So it's suppressing queries out to the branch 1 router, and branch 1 is only advertising its connected and summary routes. That's it, right? So we could leave it connected in summary, or we could change it if we wanted to, but again, it's limiting the size and scope of the query domain, because if for whatever reason the HQ router, sorry about that, the HQ router, let's say it loses this link here. It's going to send a query out here. It's going to send a query here. But now that this is a stub, By virtue of the fact that the adjacency reestablished and the hello packet is indicating from branch 1 to the HQ router that, hey, branch 1 is a stub, when that EIGRP interface is lost, HQ is not going to send a query out, because by virtue of the fact that we have stated that branch 1 is an EIGRP stub router, HQ understands that really what, in plain English, what branch 1 is saying is, do not bother me with your query messages, HQ. I am not going to know how to get to whatever destination it is that you're going to be asking me for. So don't even bother. And that is what the stub feature is all about. And so it limits the query domain to right there, right? Well, probably better to say even right there. The query isn't even going to be sent, right? So if there were other routers back over here behind branch 1, right, then they wouldn't get notified either. And when we're dealing with low-speed links like this could become critical and crucial in terms of your time to reconverge, or for the successor route to move from the active state, which it would be in as soon as the queries are being sent, to the passive state. All right, so we went ahead and took care of our default routes. Let's see what we've got here on HQ now. So if I were to say, and actually, I apologize, let's finish up here. So we're going to turn branch 2 into a stub as well. So router EIGRP1, I think we might have already been in there, EIGRP stub. So that's going to turn that router into a stub router, and then we'll come to the distribution as well. And we'll say global config, router EIGRP1, and then EIGRP stub. So what does it look like now on HQ? So we come back over to HQ, do show IP route EIGRP. So HQ still has full reachability, right? He still sees everything, and that's exactly what we were looking for. And let me check, let's make sure that we've got this here. Establish full connectivity. I think I'm missing a step here. Process ID on both branches. Okay, we've got the default route taken care of. Distribution center has many networks. Okay, it should get a single, so we're going to summarize on the distribution router, and then we're going to do variance, unequal cost load balancing. So let's take a look at the distribution center. Since it has many networks, let's see what those networks are. Do show IP interface brief. All right, so it's a series of 10 networks, and so we need to summarize those networks, and we do that simply by taking a look at the interesting octet. Well, which octet is the interesting octet? And the interesting octet is defined as the first octet where everything is, everything is not the same. So it's not that octet, it's the second octet, as you can see here. So we start with 0 and go to 6. So this should be pretty straightforward. We'll do 0 first, and 0 is our easiest one, right? So equals 0. And then I'm going to go ahead and say that those 4 bits right there will always be the same. So then we've got 0, we need 1, so 0, 0, 0, 1, and then 2 is 0, 0, 1, 0, 3, 0, 0, 1, 1, 4, 0, 1, 0, 0, 5, 0, 1, 0, 1, and then 6, 0, 1, 1, 0. So then we take a look at these bits, and where do they no longer match? So we notice it's right there. Right, so they stop matching here. So again, the little trick here is 2 raised to the number of bits left over that don't match tells me how many networks this summary is actually representing, even though we have 1, 2, 4, 5, 6, 7. It's actually representing 8 networks, and we know that the next network would be 10.7.0.0. So we're actually going to be pretending or fronting like we're representing the 10.7.0.0, but we have all of the networks except for that one. So then we take a look. We've got 1, 2, 3, 4, 5 additional bits in addition to the first 8 bits in the first octet that match. We know we've got a /13. Now all that needs to be done is to figure out what the value of this second octet is. Well, as you can clearly see here, it's 0. The values, none of the values bit positions are on. So 10.0.0.0 13. And that is my summary. And so 13 bits would be 255, and this would be in dotted decimal notation. And then we have the 5 additional bits. So 128, 192, 224, 240, 248. 1, 2, 3, 4, 5. There they are. So 255.248.0.0. And that's the summary that I'm going to go ahead and configure. And the key here is I'm going to configure it on both of the distribution interfaces. And so that's going to be serial 2, is that right? Serial 2.1? Yeah, serial 2.0 and 2.1. So let's get in there. So interface serial 2.0, and I'm going to say IP summary address, EIGRP. And again, this is the beauty of distance vector, is I can summarize anywhere at any time for any reason, and we're good to go. EIGRP1, and then we're going to put in the 10.0.0.0. And what I could do is not put the dotted decimal in, just drop in that /13. Right? And you can see we've got a resync. So if I say do show IP route EIGRP, what do we have here? Well, we have our summary, right? But where is the summary pointing toward? And this is critical. Remember that null zero interface, because we are representing as if, hey, I know how to get to every network in that address range. And so when I'm saying that, if something shows up that I don't have a specific match for, that it is going to go to the bit bucket. It's going to go to null 0. In other words, it's going to be drop. So we get the null interface on the distribution. Let's go into interface serial 2.1, and we're going to run that same command. So we want to make sure that it's both links are advertising the same thing. So now when we come back up to HQ, you can see that the table was rather crowded there. But now what happens? Again, all of the more specific EIGRP matches, those are gone. Those 7 networks are gone. They've been replaced with a single network. But let's remember, the key and the value add of summarization, the primary value add of summarization is not shrinking the size of the routing table when we type show IP route EIGRP or show IP route. The primary goal of summarization is to limit, to increase stability, right? Because I can lose a member of the summary and the summary will still be out there as long as one member, more specific member in that summary exists. Then the summary is not going to go into the active state. And so that's what we want, right? That provides stability, but it also limits the size of the query domain, because if the HQ router were to receive a query for something in this summary range that's not specifically that network 10.0.0/13, it's simply going to say, nope, don't know how to get there. Sorry, right? And that's what we want. Okay, so we've clearly shrunk down the size of the routing table. So the last thing that we need to take a look at, and let's say do show IP EIGRP topo, are the links that we have and the cost of those links. We've got the summary quad zeros, but here's what we're looking for. So you can see we've got these 2 links over here. If we go to the diagram, we have these 2 links between the HQ router and the distribution center networks across these serial links. Now this is only 1 megabit a second, and this is 2 megabits a second. So they're probably not going to be equal cost capable, and as we can see, they're not. So here is the P for the passive state. Here is the successor route. Again, that's our summary. We have a single successor. We know that successors are always listed first. So that is the successor route. We see the feasible distance, which is the value, the metric of that successor route from the last time it went from the active state into the passive state. And that is when this feasible distance value is set. Remember, that column right there, that is my computed distance, which at this moment is the same as the feasible distance, but that value could change. If for some reason the delay got changed somewhere along the path, we can see these values change. And the feasible distance is not always the same as the computed distance. Now, we want to use both of these lengths, and we see here that we have a feasible successor. We know it's a feasible successor because we typed do show IP EIGRP topology. We did not type all lengths, which is going to show me successors, any feasible successors, and non-successors. So I know that by typing this command in right here that what I'm going to see will be successors, and if there are any, feasible successors. And this is our feasible successor. And again, successor is a next hop router, right? And so there they are. Now, we see the reported distance here for both of these. So does this feasible successor meet the feasibility condition? And remember, the feasibility condition states that if the reported distance of the feasible successor, or I shouldn't say the feasible successor, but of the possible successor, and we'll just say boy, this is getting messy here. Let me, I'm going to shrink the size down as well because this, there we go. Let's go to medium. So the feasibility condition states that if the reported distance of the candidate to be a feasible successor is strictly less than the computed distance of the current successor, then we put a check mark. It meets the feasibility condition. And we know, because we typed that command in without all links, that this guy does meet the feasibility condition. He's listed out here, and we can see that 128,256 is less than 1.889792 million. So we meet the feasibility condition. In order to do unequal cost load balancing, rule number 1 says I must meet, I forgot the number 1 there. Rule number 1 says I must meet the feasibility condition. So do we meet the feasibility condition? Yes. Number 2 then says, okay, well, what is the variance multiplier going to be? And that's when we focus in here on the computed distance values that exist. Because basically, when we set the variance multiplier, we're simply saying that the current computed distance of the current successor, so 1889,792, that the current computed distance of the current successor needs to be multiplied by the variance multiplier value so that this computed distance value would be less than that value. So let's think of another way to say this here. So the computed distance of the current successor is this. If we multiply it by the variance, whatever that variance value is going to be, it needs to be greater than the computed distance of the feasible successor. And so just by looking at this, right, we know the variance value of 1 is the default, which means no unequal cost load balancing. And when we look at these two values here, I could pretty much estimate that 3.1 million and 1.8 million, that if I multiply that by a variance multiplier of 2, then I'm going to get like 3.7 something something something, right? Which is going to be greater than this. Now, if you can't just eyeball it and come up with the number, the best thing to do is to pull out your calculator real quickly. And let's see, where's our calculator at? Let's get the calculator out. And we simply divide the computed distance, 139,840, the computed distance of the feasible successor that we wish to use as an unequal cost load balancing link, and divide that by the computed distance, 1889792, of the current successor. and we get 1.66. Now remember that there is no there's no floating point math. It is integer math with EIGRP, and so we get 1.66. We know we need to round up because it needs to be strictly greater than, so I would round up to 2. And then that's going to pull this feasible successor link into the equation. All right, let me go ahead and clear the screen here, and let's dive in. Let's knock this out. And so we're simply going to come in on the distribution center router. And again, remember that output there, right? And when I say do show IP route, remember that for that 10.00.13, what does it show? Only the serial 10 link. The faster link right now is preferred because Dual, the diffusing update algorithm, has determined that that is the least cost path in order to get to that summary that we're advertising. So now here we're going to say router EIGRP1 variance, and I'm going to make the variance value 2. So we change the variance value, and then let's step back over here to HQ, and let's rerun that last command. And we don't see that yet. Oh, and you know what? Yeah, so we don't see it yet, and the reason why, and I'm just completely blacked out there. So the reason why is we need to do the variance 2 up here on the HQ router as well. So let's come over to the HQ router, and we're going to say, let's get into router EIGRP1 variance 2, do show IP route EIGRP. And now we have 2 equal cost paths going to the 10 network, but if I go down to the distribution network, right, and do we have that? We don't have that command in there. And I say do show IP route EIGRP. You can see that we have 2 equal cost paths. Or I shouldn't say equal cost. We have 2 paths that are unequal cost that we're doing load balancing across. I apologize. I'm saying equal cost and it's unequal cost. But the variance command has set it up so that in both directions now we can do unequal cost load balancing. And so then the question becomes, what is the ratio of the load balancing, right? Because obviously the paths are still unequal, even though we're saying that we could do load balancing across them. They're unequal cost paths. So how many packets get sent across which link as compared to the other link in this scenario? And in order to sort that out, we've already done the math, and we can see that it's just about, according to the math, it was 1.66, right? So we would round up and we would say that across that link right there, which is the lower cost link, and the way we do it is we divide the highest cost in all of the unequal cost paths. We take the highest one, which is that one, and divide it by both links. So we know that when we divide it by itself, we're going to get 1. But when we divide it by this, we get 1.66. So we would say 2 to 1. So for every 2 packets that go across our successor, we have 1 packet that will go across that feasible successor in an unequal cost load balancing scenario. All right, let me take one last quick look here at and I think that is everything in our scenario. Yeah, that is it. All right, so that is going to wrap up the challenge activity for challenge number 2, dealing with EIGRP. All right, thank you so much for watching, and I will see you guys on Monday night.